Hey everybody, Mr. Pike here again. In this video, like I was promising in the last video, we're going to be starting to solve quadratics. And don't forget, a quadratic, all that means is that we have an x squared term. So all of these are going to have an x squared term. Two very useful things to help us solve are going to be taking the square root of both sides. I'll show you when that comes up. Or putting in standard form and factoring. So what standard form is, it's right down here. We have it, essentially we want ax squared plus bx plus c. A is always useful to make it positive, so that way it just makes it easier to factor. Other than that, just notice I have this thing equal to 0. The reason I like to have it equal to 0 is if we try to factor, right, factoring is just getting something times something equal to 0. So like if I have something times something equal to 0, either A or B has to be 0 for this thing to be true at all. Right, so then I could say either that or that has to be 0 for this to be true. So either x plus 2 equals 0 or x minus 3 equals 0 for this thing to even work, which would give me the two solutions of x equals -2 and x equals 3. Right, so that would say both of those are possible solutions for that thing. So getting it in standard form and equal to 0, super helpful. Taking the square root will also be helpful. It's almost easier than factoring. All right, so let's see how this thing works. All right, example 1. We're just going to be on example 1 for the entire video. But all we're doing is determining the solutions. Then we'll put them in as ordered pairs, which are going to be x-intercepts. Well, actually, they're not going to be ordered pairs. All right, anyways, so I want to figure out what x equals such that this equals 2, 0. So I can't just take the square root of both sides here because that has an x. So I'm going to try to factor this thing. So I have an x and an x equals 0. So now I know it's going to be a positive and a negative because this thing is multiplying to be -18. So the only thing that would go here and here to make that multiply to be -18 would have to be a positive and a negative number. It can't be the same sign to multiply to be a negative. All right, so I think about the things that multiply to be 18. I think of like 9 and 2, but those have a difference of 7. I think of 1 and 18, but those have a difference of 17. What about 6 and 3? So what I can do is I can do plus 6 minus 3, such that 6 minus 3 would give us a positive 3 term right there. So the way I remember this is you learned how to add and subtract before you learned how to multiply. Right? So we add and subtract to get this term. We multiply to get that number right there. So once I have it set in factors, I can take both of those factors, set them equal to 0, and continue solving. Right? Something times something equals 0. One or both of those things has to be equal to 0 for that to work. So this would be -6. This would be 3 when you subtract 6 and add the 3. That's it. All right, moving on. Same idea. Can't take the square root of both sides yet. I'll show you when that kind of happens, what we're looking for. So I'm just going to try to factor this thing. So it looks like, since I have 5 there, since I know it's multiplying to be a negative, I have to have a plus and a minus. 6 and 1 probably not 2 and 3, even though 2 and 3 add to be 5. Since they're different signs, we need the difference to be 5. So I want to have -6 plus 1 so that -6 plus 1 is -5. So I will take both of those, set them equal to 0, and solve. So that I have x equals -1 and x equals 6. Those are both my solutions. Moving on. 2x squared minus 11x equals 6. So notice this one. Both of them before, we've had it equal to 0. So here I'm going to have to move over the 6 in order to make sure this equals 0. So 2x squared minus 11x minus 6 equals 0. So now with factoring this one, this 2x squared is important to notice because that means I'm going to have 2x and x as my first terms instead of just an x and an x. I got to do 2x times x gives me the 2x squared. All right, so now for the rest of this, I need to multiply to be 6, so it could be like 3 and 2 or 6 and 1, and I need to add to be 11. So since this is a minus and this number is so high, I'm going to guess that I have -6 and +1. So the reason I guess that is because when if I were to distribute this back out, I am concerned about those terms right there. I know that 1 times -6 will give me -6. I know that 2x times x will give me 2x squared. So it's really just the question of 2x times the outside term and the inside terms together. Make sure they add to be the middle term. Well, if I do 2x times negative 6, that's negative 12, plus 1 times x, so negative 12 plus 1 will give me negative 11. So I know I factored that right. If you're ever not sure, just multiply it out. Multiply it out and you will check to make sure that you are correct. Then I can take both of these, set them equal to 0, and continue to solve. So I'd have to subtract 1, divide by 2, so x equals negative 1/2, and x equals 6. I did write the equals here. And those would be my solutions for that one. All right, moving on. Same sort of idea down here. Notice we're equal to negative x, so I'll need to add that x to the other side. So I have 3x squared plus x minus 4 equals 0. So I'll factor this again, but notice this time I'm going to need a 3x as my first term, such that 3x times x will give me the x squared. So now, if I have minus 4, it could be 2 and 2, could be 1 and 4. I'm going to guess 1 and 4, and I'm going to do minus 1 plus 4, because then 3 times negative 1 is negative 3 plus 4, which will give me positive 1 in the middle. So then I can take both of these, set them equal to 0, and solve. So x equals negative 4 over 3, and x equals 1. There's both of my solutions. All right, moving on. Got more junk, man. All right, so I can't factor this side to make it nice, so I'll show you what I mean by that in a minute too. So I'm going to move over the 5x, I'm going to move over the 10, such that that side equals 0. So I have x squared minus 3x minus 40 equals 0. So now that number is pretty small, so it's probably 8 and 5. So x, and the things that I think about first are what multiplies to be this number, and then I think about the factors that I could add or take a difference of to get the middle number. If you're wondering why I'm thinking of 8 and 5 so quickly. I've also done these for a while. All right, so I know I'll set both of these equal to 0, so this one will be negative 5, and this one will be positive 8. There will be both your solutions for that. All right, so now notice, like I said in the beginning, I like to have this to be a positive x squared. So what I'm going to do to get rid of that negative is I'm going to multiply my entire equation by negative 1. So long as I do it to the entire equation, both sides, this is completely mathematical. Well, yeah, a little bit, but mathematically correct. That's what I was going to say. All right, so we have x and we have x. Probably going to be 9 and 6, so I'm going to do plus 9 minus 6, because they multiply to be negative 54, they add to be 3. So I have x equals negative 9, x equals 6. Good money. Moving on. All right, here's one. Notice we don't have an x term, so here's one where it's going to be kind of cool to take the square root of both sides. So to get rid of this square, if I take the square root of both sides altogether, this will come out as x equals 7. Now something important, whenever you take the square root, you need to have a plus or minus with that. There are two solutions. The reason for this is because if I look at my original equation, the x squared equals 49. If I put in 7, 7 squared is that 49. Likewise, if I put in negative 7 squared, that's also a positive 49. So we'll learn later as well, and whenever we take an even root, got to have the plus or minus with it. So your solution here, I already wrote it, but I'm going to write it all in the same color so you know it's all the solution, is plus or minus 7. You could also write it x equals 7 and x equals negative 7. You could also write it x equals 7 and negative 7. However you want to write that. But there are two solutions. It's the positive 7 and the negative 7. Ooh, that was close. All right, so this one, two different ways you could do it. You could recognize that this is a difference of squares. I don't want to talk to you. Don't text me. Just this way I don't, you guys email me. I don't like text. All right. So you could notice that this is a difference of squares and do x plus 4, x minus 4. You could also, what I like to do is just move that 16 over, and I have x squared equals 16. So when I take the square root, I can do x equals plus or minus 4 and be done. I don't have to think about factoring at all. If you have an x term involved, though, it doesn't work out so well. However, here's one that's pretty cool. Because this is a perfect square factor, so we can factor it as x plus 3 squared equals 17. This is going to save us a ton of time. Because what we can do at this point is take the square root of both sides so that this x plus 3 squared is now just x plus 3, and I have equal to plus or minus, I don't know what the square root of 17 is, so I'm just going to leave it as square root of 17. From this point, all we need to do is subtract over the 3, so I would ask that you leave your answer as negative 3 plus or minus square root 17. Just be able to recognize that this is two separate solutions altogether. This is the solution where x equals negative 3 plus root 17, and x equals negative 3 minus root 17. They could switch it up on you and put it as this in apex. They could switch it up and put it as this. They mean the exact same thing. If you were in my class, I would be fine with this like this, but notice the apex stuff, sometimes they split it up, because I don't know if they just don't want to type the plus or minus, who knows, but it is both solutions. So make sure you guys are looking out for both. Whenever you take the square root, you need that plus or minus on it. All right, we only got FOMO. FOMO for yo. All right, so this is another one. This is a perfect square factoring case. So this will factor as x minus 4 squared equals 12. And then I can take the square root of both sides such that I have x minus 4 equals square root of 12 plus or minus. So here's something as well. If you have the square root of 12, you guys learned in geometry in Algebra 1 that you can break these down. The square root of 12 is the same as the square root of 4 times the square root of 3. Now the reason I chose the square root of 4 is because we know the square root of 4. If it were a bigger one, if we had like 18 say, this is square root of 9 times square root of 2. Because I know the square root of 9. Yeah, 6 times 3 is 18 as well, but I don't know the square root of 6, I don't know the square root of 3. So pick numbers that you know the square root of and see if they multiply to be that number. Because now this is 2 root 3, this would be square root of, 3 square root 2. Square root of 4 is 2. I don't know root 3, even though I know it's 1.732. Square root of 9 is 3, and I don't know square root of 2, even though it's 1.414. So this is how Apex will be writing it. They will be reducing this. We'll get to these later on in this course, as well as how to reduce like third roots, fourth roots, fifth roots, so on and so forth. So from this point, all I'm going to do is add over the 4. So I have 4 plus or minus, and then I'm going to write the square root of 12 as 2 root 3. Again, remember, they could split this up in Apex for you guys to make it 4 plus 2 root 3 or 4 minus 2 root 3. Could see either one. They're both acceptable answers. All right, with this one, I have just a perfect square on this side, so I can just take the square root. Don't forget that plus or minus, so that I have x minus 4 equals plus or minus square root 19. I'm going to add that 4 over, so x equals 4 plus or minus square root 19 and be done. Yeah. All right. And 19 I can't break down. That's a prime number. Nothing multiplies to be 19, so I'm just going to leave it like that. All right, here on L, notice that I almost have one thing squared, but it's not exactly right. Just like we did in our absolute values, I need to get the square by itself first, such that this is x plus 1 squared equals 6. And now I can take the square root of both sides. So square root. So x plus 1 equals plus or minus square root of 6. 6 is 2 times 3. That's the only factors it has other than 1 and 6. So I can't break it down any further. Break it down now. So I'll move over that 1. So negative 1 plus or minus square root of 6. And that's it. Again, negative 1 plus root 6 or negative 1 minus root 6. Either way. All right, last one. So again, just like I was talking about in this last one, we need to get that term by itself, because then we can square both sides and make our life a lot easier. Get out of the way, phone. Nobody likes you. Nobody knows the trouble I'm in. That's not really the tune of that song at all. All right, so I would subtract the 13 first, so that we have 3 times x minus 6 squared equals 51. And then go ahead and divide by that 3 to get our squared term by itself, so that I have x minus 6 squared equals 17. Now I can take the square root of both sides. Don't forget to put a plus or minus whenever you take the square root. So I have plus or minus root 17. And then add the 6 to the other side, so x equals 6 plus or minus root 17. That's 17 right there. 17. And again, don't forget, Apex will write this. I know I've said it like 3 or 4 times, but I'm just trying to make sure that it gets in your head. They could say x plus root 17 and x minus root 17. Those are your answers. This is how you can write it in the classroom, and it'll be perfectly acceptable as well. All right, hopefully this video was helpful. I'll talk to you guys soon. Let me know what I can do to help you guys out. Bye!